Hey guys, welcome to this video, and in this video we are going to see how we can use Nginx to serve our clients and balance the load across the replicas of our backend server. So what we have in our screen is a client which is making a request to a server application. This server application is hosted on this IP. This is an internal IP for the reference. So 192.168.1.1 we have our server application running. So what happens when a client makes API request or any request to the server? Server just accepts the request, processes it, do something to it if any kind of operation is required, some image processing, or maybe just doing an authentication, and responds back with some kind of response. This works totally fine up to a certain number of clients, but what happens when there are a lot of clients? So let's see, we'll add some more clients. Let's do this. Let's add one more client. So here are only 3 clients until now, and the server application should be good enough to handle 3 clients. But what happens when these are not only 3 clients but let's say 300 clients? Maybe our server did not work so well in that case. So what do? What we can do is we can just spin up more replicas of our server. So maybe that one was running on that particular IP, which was 1.1. This could be running on 1.2. We can add one more replica which could be running on, let's say, 1.3. Now what happens is, what we can do is now we can route the traffic to different IPs. But how the client is going to decide this? How? No, the client is not capable enough to just do the round robin and predict the possible host names. That is not going to happen in a good scenario. So what do? We introduce something else. We have a really good tool called Nginx, and Nginx has a pretty awesome functionality which is called load balancing. So let's give this block a name, Nginx. Let's call it Nginx load balancer. And now what happens is, this is also a service, so this is also given an IP. Let's say this has an IP of this, which is 192.168.1.0. Now what happens is all of our client applications are now making API requests to our Nginx load balancer. This could be 100 applications, like 100 client applications, doesn't matter. All those are making API requests or any kind of request to 192.168.1.0. Now our Nginx load balancer is configured in such a way that it is routing the traffic to all of these servers. Now this functionality is there in the Nginx already. So now what happens is, if our clients are making any request to this particular host name, Nginx is routing the traffic to either of these, which could be like 1.1, 1.2 or 1.3. Now let's take an example. Let's do a demo right away and see how this can be implemented in real world. So let's create an application here. So we have a folder application. Let's go inside the application folder. I'm going to use Python, and we can create an application using FastAPI, a very lightweight application. It does not matter really. You can build an application with Express as well. So just for sake of this example, we are going to use Python. So we will create a virtual environment. First of all, let's see which version we are using. So we're using 3.12.0. So we have our environment created here. Let's activate the environment, and we can install. Before installing, let's upgrade our pip to the latest version, and now we can install FastAPI and UVCon. Let's save these to requirements.txt file. So we have everything saved here. Now let's create a main.py file, and here in this file we can create our application, a FastAPI application. So what do we return? We can return, let's see what we can return. So I'll import socket, and from socket we have something called get host name. So we can just get name of this host and return it. I'll save this, and I'll run the server using UVCon. I'll run it on port 8000. So it seems the application is now running. Let's go to the browser and run our localhost server. It's running on port 8000. So we can see that it's returning this host name. Now what we can do is let's dockerize this, and so I can create a Docker file, and we can use 3.12.0 Alpine as the base image. We will declare a work directory. Let's first of all copy your requirements to our newly created work directory. Now we can run. First of all, we can update our pip, and then we can install the dependencies. Once the dependencies are installed, we can then copy our other resources, other files. Now we don't want our environment and PyCache folder to be copied to our Docker. So what we can do is we can create a Docker ignore file. And we can write this thing, CNV. So once we have these, once we have our Docker file ready, what we can do is we can come back to the root folder and create Docker compose file. We can put a server as well, no problem with that. Let's use version 3. Let's declare a service, call it app1. We're going to use our app directory as the build context, and it will use the Docker file which is declared, which is defined there. Let's also give it a name. Let's give it app1 as a container name. We need to provide a command. We could either give the command here in the Docker file itself, or we can override the command here. So we can just give the command here and use our this command that we declared here, that we used earlier. Now what's happening is UVCon is looking into the main file and using the app object as our application. We're defining the host, we're defining the port 8000, and we want the hot reload functionality, but for that we have to mount our volumes. So let's mount the volume for development purpose. Please note, we usually don't mount our volumes in the production environment. So where do we have our volume mapping? We have it in the host system, we have it in the app, and in the container we have it in our app directory as well, so no problem there. We also need to map our ports in order to see the changes. So let's see, port 8000, host port 8000 mapped into containers port 8000, or let's say 8001. Once we have everything ready, let's deactivate the environment. I'll just zoom this a bit. Now let's run our Docker container, or build our Docker container. seems our server is running. Let's go to the browser. Port was 8001, and yes, it seems to be working. And now we have a random host name assigned here, which is being returned. Let's do one more thing. Let's run some replicas of this application. Say app1. You already have app1, so you can call this app2, call this app3. Now this hosts 8001 port is already being used by app1, so for app2 we will be using port 8002. For app3 we can use port 8003. Now stop these containers. There's only one container, so we can rebuild these with 3 new containers. You can see all the 3 containers seems to be running. Let's see what we have. So 8001 is still working, 8002 is also working, 8003 is also working, and if you can see that all 3 are assigned some random host names. So all these 3 are quite different. Now where we are. So until now from our diagram we don't have the Nginx configured yet. We are identifying the servers manually and making the request to them. So we want our Nginx to be there in between and resolve, like it should handle that load balancing for us. We do not want to care about the load balancing. So let's go back to our Docker compose YAML and we can spin up a new service called Nginx. We can use the Nginx image directly. Let's use Alpine as a lightweight one. We need to give it a container name. Let's call it Nginx. Also by default there's the server that is running is listenable on port 80, but we want to listen that we will be mapping that port to our systems, our host systems port 8000. So let's do that. The main thing is the configuration, so we need to create a configuration and map it to a volume. So let's write the volume first. It should be here a directory called Nginx, and we can create a file by the name of nginx.conf, and this should be mapped to an Nginx predefined directory. So where do we want to map it? First of all, let's see what are the contents of that configuration file. So you can just directly go to Google and search for Nginx sample config, and here is the official documentation by Nginx, and we can see we have nginx.conf, and there are a whole lot of different things, but today we are just going to focus on the load balancing. So we can copy this server block and just paste it here. What we can see is, if we just remove this command, we will see that it's listening on port 80. There's a server name. We don't have any domain, so we can also specify underscore, which is kind of a wildcard. We don't want to save any access logs, and if we receive any traffic on the slash or the root, we will just proxy pass to this thing, which is big server com. Let's give it our own name. Let's call it app, but we do need to define it somewhere. Let's go back to the documentation and we'll see that the big server com is defined here. It's something called an upstream. Let's copy it and paste it here. What can we see? So we change the name to app, so we'll do the same here. We can see that it has some servers defined here. So here are 4 different kind of servers. We can just remove 3 of these. Let's ignore this weight as well and give it a name. What name should we give? So if we go back to our Docker compose, we'll see that we have 3 servers here. 3 services basically are app1, app2 and app3. So these service names can also be used to make request, HTTP request to them. So we can just write app1, and app1 inside the container some service is running on port 8000, which is our FastAPI application, so we'll define port 8000. We also have two more servers, app2 and app3. Let's write those as well. Save this file and let's go back to our Docker Compose YAML. Now we need to map it somewhere. Let's see, where do we need to map it. So here we can map it to /etc/nginx/conf.t and default.conf. So there's a default configuration here in this particular location, and we are just overriding that with our configuration. We can save this and stop these containers from running. Let's run this again. Let's see what happens. And what seems is our Nginx is also working. Let's go back to our browser, open a new tab, and it's running on port 8000. So port 8000 seems to be working and returning some ID. Now what will happen if we refresh the page? Let's refresh it, and yeah, you can see that the ID has changed, which means something is happening. So what's happening? So as we mentioned here, the load balancer will distribute the load among all the servers that we have defined there. So there is some algorithm running inside Nginx, which is called round robin, which will one by one serve the traffic to each of these servers. If we refresh the page, you'll see each time a new host ID is returned. So what's next? So now let's see. So we saw that there was something called wait was defined there. So if we go back to documentation, you can see wait 5 is defined here. So what is this wait? This wait basically means how much weightage, or basically what is the portion of traffic this particular server is going to handle. So let's say we want to handle 80% of traffic on this one, 10% on this one, and remaining 10% on app3. Now if we rebuild those containers, server seems to be working fine. Let's go back to the same tab and refresh this sometime, like multiple times. You can see 422. Now it came for like 3 to 4 times. Now we have 9C2. 422 is now coming again. Now we have 753. So I refreshed a lot, and seems that 422, this one is coming a lot, which means our wait is also working totally fine. Let's do one thing. Why not create a new file here, and test it separately. Let's install requests, and what we can do is write a function here to make API request and see how much one server is handling. So what we can do is we can define our max requests here, and let's say I want to make 100 requests so far. So we have a script ready here. Let's see what it does. Okay, so what you can see is it made 100 API requests, and it seems the server with host name 422 handled in total 80 requests. With 9C2 it handled around 11 requests, and 753 handled around 9 requests. So it is approximately 80, 10% and 10%. This is what we defined here. It is not always 100% same as we defined here, but it is like very precise to it, very close to that number. So that's it for this video. I hope you guys found this tutorial really helpful. If so, please don't forget to hit like and drop a comment and subscribe to this channel. Thank you so much.